Welcome to wasmCloud Wednesday for March the 23rd, 2022. We've got a fun meeting today, including a big update on the machine learning capability provider for wasmCloud. So we'll start by handing it off to Steve, who obviously does not have the ability to share his screen. All right, Steve, you want to give us an update? Let us know how things are going with the collaboration you've been working on with the developer from BMW, Christoph.
Yes, hi. Christoph Brewing has been working on a machine learning capability provider using an Onyx model. And he's going to demo that. He recorded a video earlier today. He's in Munich, Germany, and wasn't able to attend the call. But I'm going to show this demo that he recorded. All right. Oh, what is this? Please. Oh, no. Please install the Zoom audio device.
Sad trombone noise. Okay, you gotta love the live demo. You got it? Steve, can we hear you?
Yeah. Do you guys see the?
Yeah, we see it.
Okay, I'll just play it.
Hello, this is Christoph Brewing from Munich, Germany, and today I'll show you around our machine learning inference capability provider and the application we build around it. So in that architectural drawing, you hopefully see here on the screen, you'll see a picture of the application. There's in the center, in the big rectangle that illustrates our wasmCloud runtime, there are multiple artifacts. The smaller rectangles that are capability providers. We have got an HTTP server, and that is also an endpoint to the application on the lower left. And on the top right, we have the capability provider, which does the inference processing, so the machine learning processing. And it's marked IE, that's for inference engine. However, that's misleading a bit because we already have more than one inference engines implemented in it. However, now you know what it represents. Then in the wasmCloud runtime, in form of circles, you have actors. We have two of them here. The one is API, so inference API, that's directly connected to the HTTP server. And the other one marked I, you can imagine it not being there. It's not implemented. We intended that for first iteration of the application. It's not important. Outside of that wasmCloud runtime, you've got the Bindle server. The Bindle server is a kind of a blob store, and that's where we used to store the AI models as well as some metadata. So what happens is if you process requests against that wasmCloud runtime, they come into the HTTP server, are routed via the inference API to the capability provider who does the processing, and the response going back via the inference API and the HTTP server, so that you will receive hopefully a 200 OK response with the result of the inference processing. However, as I said before, the processing can start, the capability provider, i.e., has to download all the models, and that is done during startup of the application. So, having said that, let's see how we can get you up and running such that you can replay what's already pre-configured in form of different models and also scripts in the repository. Don't worry about the repository URL. You can ask for it in the Slack channels, and I think you will get a quick response. So one of the preconditions is that you have installed Bindle server. As far as I know, you can install any version node. However, that versions later than 0.7.1, you have to deal with keys, so they harden the security aspects. So for development purposes, I use 0.7.1, and you do not have to worry so much for security. What else do you have to install is that Docker and Docker Compose. I referred to the page of wasmCloud. They have got a good guide, what you have to take care of and what you have to install. Otherwise, we may directly jump in and start the application now. Let me see if I have it ready for us. So before you can replay the application, as I said, you have to load the Bindle server with the models. So luck for you, for us, the models are pre-configured in the repository. So let's see how you load them up into the Bindle server. Once you have cloned the repository, go into the deploy directory, and then we have a start script called run. This is your friend. If you just type it, you get all the subcommands. And in order to upload the pre-configured model, run bindle create. So it will create the it will upload the pre-configured models, upload them to the Bindle server, which is started at the same time. So you do not have to worry to start it. And then you should be good to go. You get some log information. And if it looks like that, this is fine. You have to do it only once. So once you've uploaded the models and the metadata to your Bindle server, you do not have to do that again. So whenever you start or stop the Bindle server next, you can do it with the other subcommands. You see Bindle start and Bindle stop. So that's started now. It's time to start the application. And that is done via run all. So what's starting is NUT server. We have a local registry where we pull the actors and capability providers from. Of course, the runtime itself, the Bindle server is already running. So now if you go into the log directory of the wasmCloud host, you can see, hopefully, files named erlang.log.something. And if we print them out, you can follow up the logs. So while the application is starting, we may have a look at the washboard, which is getting more and more complete. What do we see at the washboard? We see the application starting up with all its technical stakeholders. So at the top right, we already have the ML inference capability providers. You see its status is healthy, so it's up and running. On the lower left, you see two links. So one link is between the HTTP server and the inference API actor. The other link links the inference API actor to the inference engine, so to the capability provider who does the processing. And the inference API actor itself, you see on the top left. So meanwhile, the HTTP server started up, its status is healthy as well. It takes always a bit longer. So now we are up and running. That should be reflected in the logs as well as in the output. And now let's have a few requests running. So I've pre-configured 2 requests. The first one is a request against the Onyx inference engine. Its model is called identity. What it does is, so the model is configured such that the output of the model is always the input, so it yields what it gets. It's not particularly interesting for real-world use case. However, in case that works, you know that the application is up and running and works well. And if we trigger that, you see we get a 200 back, and also we get a result. And if you compare that result, you see a field has error is false, so that's good already. If you compare the content, you see that the content is identical, in fact, to the request. That's fine. So that's a request against the Onyx engine. Now we also support Tensorflow Engine. So we've got a second model. It's also pretty, say, simple. However, not another identity model. It is a +3. It adds 3 to every field in the data, what it gets. So let's just post it. See that we get back a 200. And now if you closely compare the data of the response to what we put in as a request, you see that's not identical, in fact. And these data, I mean, that is serialized to byte array. But if you deserialize it, I don't know if I have it prepared for now, you will see that, in fact, there's a +3. I scroll down the README of the current repository, and there we have it documented somewhere. So this is exactly what we got back. And if you deserialize that into F32, you see that it incremented, now it's down here. So it incremented every input by 3. That's why it's called +3. Yeah, that's it. That was the 2 examples. So if you want to replay that, have problems, or if you want to implement your most wanted feature, contact us in the Slack channels. And that's for now. Thank you. Bye.
I really wish we could give Christoph a round of applause. So Christoph, if you watch this later on video, that was awesome. I know that you have been working on that for months, frankly, on collaborating with the folks at Intel and with Steve and other folks around the community. And that is incredibly awesome. Steve and Andrew, I know you guys are on. Any thoughts or perspective about where we are, things you want to share in addition to the video?
Nice
Steve,
job, Christoph. That's my comment.
All right, Steve, you're on mute.
Yeah, just a sec. I have an audio problem.
Okay. Andrew, what do we need to do? I know Intel's got a bunch of customization that you guys have done to speed up the TensorFlow work on your chips. Is there anything special that we need to do to use that, or is it baked into and supported in TensorFlow just out of the box now?
It should be supported in TensorFlow after a certain version, and I think that version happened a while ago. So if you're using the latest from TensorFlow, you should be good. But once we sort of start doing actual inferences and classifications, we could probably check that. That'd be something interesting to sort of analyze.
Steve, are you in a spot where you can chat?
Yeah,
or we can talk to you later
yeah, I'm back. Sorry about that. So yeah, this is really exciting work. So over the next coming days, we will check in an interface to the interfaces repo that's based on the wasmNN work that the Andrew and his team at Intel created, and we'll also put the capability provider in one of our repositories. So I think you might have seen Christoph's GitHub repository. It's finfalter on GitHub, and so go ahead and play with it there, and it'll keep evolving. So it's real exciting work. We're also working on some image processing demos, which should be out soon as well.
Yeah, we'll get some demos out that have a little bit more eye candy for folks for walking around with and iterate through those. Steve, I want to invite you and Andrew. I know that one of the big lessons learned here in implementing this was that we may want to evolve the wasmNN piece a little bit here. Is there anything that the two of you would like to speak to about what you guys have kind of come up with and decided? I think it ended up accepting about half of this proposal. Is that correct?
Yeah, I think one way to think about it is that you design an interface based on the anticipated needs, and then once you get down into implementing things, you realize that the interface needs to change for real world use. And so the interface will have to evolve a little bit as we go and play around with it.
Yeah, I'd agree with that. And Steve, I was just talking today with Brian, another one person on the team, and there might be other uses for flags that we might want to think about. So yeah, definitely open to changing the spec and adapting it for real world usage.
Okay. All right. That's awesome. And I think you guys took the right strategy for whatever it's worth of continuing to push forward to get an MVP out, and then looking at iterating the spec earlier, because I think that there's a lot of people that are searching for, an easy cost-effective way to run distributed machine learning. And the demo that I really dream of is us building like the build your own nest, in 15 minutes, right? That's the demo that I think we're like, I could see it in our near future, like wasmCloud gives you all the distributed, and yes, we would need a video capability provider, but there's just so much low-hanging fruit here for people to pick up and run with.
Yeah, one of the areas that's under active development that's a kind of interesting problem space is deciding where to do the processing. So in wasmCloud, we have actors that run in WebAssembly and capability providers, and depending on your situation, you might want to run the inference model in an actor. For example, you might want to run it in a browser or on somebody's edge device, cell phone, because that improves your privacy. You don't have to send the image or all of the raw data to some cloud provider. You can keep it right there, either on your device or maybe on your home LAN or your office LAN without sending it to a cloud. Or you might want to send it to a provider that's got a high caliber engines with optimized instruction sets and banks of GPUs. Or you might want to be able to make that decision on the fly based on what's available and how big the information is or the needs of the application. If you need something real time, or you're willing to wait an extra couple seconds. So this is probably going to get implemented both as an actor and as a capability provider. And so there'll need to be supporting libraries to support either of those use cases. But we, and of course, all the other things you get with wasmCloud, like the failover, the dynamic failover in case one server's down or one cloud provider's down, to be able to send the data to another location to be processed. So there's a lot of really interesting combinations to play with. And so this is going to end up being a really flexible environment.
I think for me, this is Andrew, something that when we talked about this, it felt really insightful, was when we think about wasmCloud, if these are all edge devices out here running on low power, CPUs, or even, more powerful things like, the Coral AI from Google, or the NVIDIA Jetsons, or something like that. The idea to be able to offload or choose which capability provider you're running, because this is one of the new Intel Tensorflow optimized CPUs running in, GCP, for example. Those are really powerful concepts and ideas. And I think that's a real advantage to the wasmCloud capability driven approach, and how the combination of wasmCloud, machine learning, and distributed environments just really can come together in some neat ways. Did you have a comment to make? You just came off on video.
You're talking about to me?
I'm not sure. Jay Marger. Yeah, I'm sorry. I didn't get your first name.
No. Well, I'll hopefully be presenting in a few minutes. That's why I just tested my camera.
Oh, okay, great. Super. Awesome. Well, are there any questions for Steve or Andrew before we move on to the next topic? Okay, that's right, Jonas. We had talked on Slack about you presenting today. I'm so sorry for that. I did want to ask you one quick question before we move on. Steve, I know a lot of machine learning stuff is done in Python. Are we talking about the Python capability provider you're working on, or is that still like something we're not talking about?
Yeah, I'll check that in as well. So Python, of course, uses the C libraries and the Intel optimized TensorFlow as well. So you get all the flexibility of the language and the QRS libraries, which make it so you can write a capability provider in 10 lines of code, which is pretty amazing. So yeah, that'll be rolling out soon as well. It has it inherits some of the Python limitations. There's a global interpreter lock, if you're familiar with Python, which means it can only do one thing at a time. So it can't really take advantage of lots of CPU cores, but there are some partial workarounds to that. But it's definitely got lots of flexibility, and I think it will be a great addition to our capability provider set.
That's awesome, Steve. We'll hopefully get a demo of that maybe next week or the week after. And Jonas, I'm so sorry. We talked about on Slack about you demoing today, and I don't know that I've ever actually met you face to face. I know we've chatted a lot on Slack quite a bit. Would you want to do a quick intro of who you are and what you've worked on? Because I know everybody's going to recognize your project as soon as you share it.
Yeah, great. Thank you very much. My name is actually Jonas. That's the pronunciation in Swedish. So I guess, I mean, the introduction is part of the presentation I'll be holding here. So I'll wait for that, I guess, if you don't mind.
Okay, that's great. So actually, let me give you the ability to share your screen, make you co-host. And are you going to do a demo and kind of talk through what you're working on?
As I just wrote to Brooks, I took the opportunity to make sort of a more general presentation and hopefully to make it entertaining in the spirit of Ninjas. Yeah, I'll hope you'll like it.
Great, I'm so excited, and you should be good to go.
Okay, so let's see here. Trying to go full screen. There we go. To start, a lot of people end their presentations with a slide like this, but I wanted to actually break the norm here and start with this slide, because I mean I got a lot of attention when I posted my demos in Slack, and I'm really grateful for that. Really grateful for the praise I got, and really, and also I wanted to thank you for, I mean, just the wasmCloud in itself. I mean, I'm a developer who has quite a lot of back-end background, and I know what a tremendous amount of effort it takes to put together something like this, and I'm really impressed, and really I'm looking forward to see all the development that is to come with this framework. As I mentioned, I think I'm from Sweden, and I mean, Sweden is a great country, but I wanted to to tell you that, I mean, if you ever think about moving to Sweden, you should actually think twice. And one of the hazards is that you really have to be careful what you say yes to in Sweden. The thing is that Swedish in Swedish, if you separate parts of words, they can have wildly different meanings. So, I mean, full stack developer in English, you have this practice of having each word separately, but we usually, I mean, eliminate the spaces a lot of times and fuse the words. So in our, if you would say full stack developer, I've come across you could call it a sloppy way of saying it, which is full stackare. So, and this is an example what I was telling, that the other day I got this message from a recruiter on LinkedIn, and she was asking me, well, could you be our next full stackare? And just like in English, she separated the words, but actually that gives it a totally different interpretation in Swedish. So actually you would interpret that full stackare as a drunk person that you feel sorry for. So yeah, well, I had to say that well, I declined. I regretfully declined. So, well, you should know that before moving here. Anyway, moving on. So, some of you at least have seen the Ninjas demo, and this was a demo that I put together for a presentation that I had at work about a month ago. And I wanted it to be really an eye-opener, just to get people's attention and to see what is possible with some modern web APIs and also with wasm. And as I said, I got some really wonderful reactions from you, Liam. That was really great comment. Yeah, I got everyone's attention, and Brooks. I mean, to get praise like this from I mean, seasoned developers, that's all you can ask for, really. And then well, while this is from the Red Badger We Love Code conference, and while this is a bit more muted, I really appreciate it, and I can also sense a bit of ambivalence. I mean, is this amazing, or is it just silly? So, well, I'll try to answer at least, I mean, my view on that and why I made this demo. And the other demo I posted was this, and this was demo that actually used wasmCloud. And this is an implementation of the 2048 game where you move these tiles around and fuse them. So, I mean, it's a really, I mean, enjoyable game. I like to play it myself, and that says a lot about, I mean, if you've developed something and you still like to use it, that says a lot. And also, I mean, it was a great project to explore wasmCloud, and it was also became a great piece of the presentation I held at work. We had a competition with prizes where people could play this. So anyway, and I'll talk a bit more about that also. So yeah, and talking about that presentation, we'll see. I'll bring up actually the first slide of the presentation I held at work, and now the bandwidth hasn't gone down. You don't worry. This is the low res is just part of the obvious 80s theme, and the presentation itself was built around me showing off or flexing my newfound wasm skills. Well, yeah, I forgot actually. Let's see. I had, let's see, this slide here. So, I mean, as a page from presentation 101, you should always include this. And I was about to forget it. You should include that slide, and that was what Liam asked about, also something about me. But actually, I realized that you already know quite a lot about me. So, well, as you might have realized, I really like informal and entertaining presentations. And I'm not a full stackare. I really would like to have that opportunity and have the audacity to put that on my LinkedIn profile. But the truth is that I don't drink, so I can't aspire to that, really. So Liam usually introduces himself as a serial entrepreneur. Well, I would say in that spirit, I'm a serial developer. I've been programming since the age of 9, and I've been programming professionally now for 20 years in 20-something languages, actually. Well, while it's part of the Swedish national spirit to be modest, I can safely say that I'm not a junior dev anymore. Yeah, and currently I'm working for a research nonprofit with German origins. So going back to that other presentation, let's see, there we go. Well, I mean that presentation is really not suitable for this audience, because I mean you've seen the demos already, so the surprise factor is gone with ninjas and everything else. You know a lot more about wasm than I do, and you definitely, of course, know all there is about wasmCloud. So what I thought this presentation would be about is, well, wasm from and this should be in quotation marks, from a research perspective, and well, my little bits of fun in that context.
Jonas, I just would want to say that while most of us have enjoyed ninjas, there are new people on the call, and
Yeah,
we have not
okay.
yet put ninjas on the Slack channel. And I want to always invite you to feel free to be yourself on this call. And if you are more than welcome to share ninjas on this call, 100%.
Oh, thank you. Well, I actually I thought I wouldn't change it or share it on the call, actually, because I think that it deserves to be shown at a high frame rate. So I think that it's something that you really should run locally.
We'll definitely put a link in the
Absolutely. I think that would be the best solution. Yeah. Yeah. Okay, so, but don't worry. I mean, you can interrupt me at any time, and I really appreciate questions, actually. So I would have started by saying that at the beginning. Research. Actually, I mean, I'll take the opportunity here to use a little bit of that Swedish word separation magic. That's why I brought it up actually in the beginning, and view it as research, because, well, my experience of research is that it's not, I mean, boldly going where no man has gone before. A lot of the time you're actually more searching, again, researching where a lot of people have sought before. So what is, I mean, this is a bit of my view on the whole ecosystem that we're seeing today. So going with that 80s theme, this is, or these are the opening lines to Zork 1, a classic text-based adventure game that I was really, I mean, it was huge in the 80s. So back in 1983, I was sitting and playing this. And while the game is great, the implementation is really, I mean, is even greater. Well, so as you can read on Wikipedia, Infocom, they who were behind Zork, they were cranking out blockbuster game after blockbuster game, really. And what enabled them to do that was that they had their own language called ZIL, which stands for Zork Implementation Language. And they had a compiler that compiled that to bytecode. And then they had interpreters for every relevant platform. So they could just crank out new games and they could run anywhere without any major changes. So, well, if that sounds familiar, I mean, it's, yeah, you can raise your hand. I mean, this is obviously something that has a lot in common with what we're seeing with wasm, for example. So another path is it starts with this. This is actually on the left. This is my dad demoing the brand new at the time System 360 from IBM. It was, they had bet most of, I mean, essentially bet the company on this new system. It cost $5 billion to develop, and that was in 1960s. So that is about $45 billion today. So they would have gone bust if this hadn't succeeded. And the product line was really amazing at the time. It ranged from the still very powerful base system, which was running at 1 megahertz, up to the really overpowered top spec system, which was running at 16 megahertz. So that's, I mean, figures like that, I think are always amazing to look back on. So anyway, so when I was going with my dad to work, the paradigm that was used was this server rendered paradigm. So you had mainframes rendering views for what was called in the 60s Slim Client, and after that they were renamed to Thin Client and Thin Clients and so on. And that carried over to, well, when I was in my teens in 1987, thereabout, that had made its way to BBS systems. You called them up on whether your modem, and essentially it was the same thing. They rendered views that were transmitted character by character to you. And then, I mean, the first time I saw the concept of client rendered was in 1989 with a product from IBM, again, called Lotus Notes, a team collaboration software that my dad used for work. And there, I mean, they had used the power of the home PCs to get that increased responsitivity and the low latency that you get when you let the client render and you just use the server with API calls that just could contain the data. And then in 1999 or 1991, we saw the first web page, and that, in my opinion, was, I mean, a bit of a step back, because, I mean, that was built on that whole server rendered paradigm. And actually, it's taken quite a while to for that to shift to a more client rendered paradigm. So in 2010, we saw the first release of Angular, which was a real usable framework for for creating single page applications with that, which I think is a really funny name, because I mean, takes the concept of pages. I mean, you're stuck in that mental frame of pages, and so this is actually, I mean, it's just basically what I would call an app, but well, what's in a name? Well, that which you call a program by any other name would smell as sweet, I guess. So and then, I mean, what triggered me to do these demos was that now I wrote 220. That should be 2020-ish, I guess. I mean, we have wasm that finally allows you to do, I mean, to use decent programming languages in the browser, because I mean, it's not really. I mean, it's safe to say that JS was never created really for large scale programs or computation. Still, people have managed to do really impressive things with it, but still, I mean, it's so much better to be able to use languages with static typing and type safety and so on. And then wasmCloud, I mean, I was really, really, really impressed by the whole concept, the idea that, I mean, to just abstract away all the communication and to get a seamless distribution that I think is really wonderful, and again really impressed by the whole framework. So that establishes the base really for my demos, and I was really when I had seen wasmCloud and what had happened to wasm since I looked at it previously a couple of years back. I was really triggered to do something like this. I mean, like Ninja, something really over the top that really could use all the capabilities, all the possibilities that I saw. So, I mean, for me, this is more than a little bit of fun. I mean, I've been thinking a lot about especially for work, how you could bring simulations, optimizations, and so on in a easily deliverable format and delivered as a web app. And this is really, wasm is really the answer to that. So there's a lot of things going on in this demo. And among those things is this pool with a water simulation driven by a C++ wave equation solver that I wrote. And you're rendering at 60 frames per second, and the pool is on the order of 100 by 100 nodes. So you're computing about 600,000 nodes per second while you're doing everything else. And while I was tempted to do this multi-threaded with web workers, I actually made everything in one thread, which I guess is actually more impressive computationally. And then you have a Lorentz attractor ODE system being solved in real time also simultaneously, and that was a solver I wrote in Rust. Then you have fast Fourier transform separating the frequencies of the audio that is playing, and which is visualized on this full wall audio spectrum at the same time. And then you have this wonderful, I mean, 3D graphics capability of WebGL, and it's not just basic 3D. You have shadows, reflections. All this audio spectrum is a light source in itself. And on top of that, you have this pretty new web API, WebXR, which enables you to experience this in virtual reality, which is really, I mean, I've been spending quite a lot of time evaluating and I mean test running the demo, but each time I step into the demo in virtual reality, that I'm amazed myself actually. So really this opens up so many possibilities, and really with this, what I wanted really to demonstrate that it is that really anything is possible really, and it's all cross-platform, and it's I mean you have this great performance and a wonderful possibility to visualize everything. So moving on then to 2048, which is the demo that uses wasmCloud. So what I wanted to do here was, of course, evaluate wasmCloud really, and the possibility to make the application distributed. And really, I had a great, I mean, again, thank you. This turned out to be a great demo. We had that competition where everyone got to play this on their phones. And the morning of the presentation, I have discovered that I actually had $8,000 left in free trial credit on Google Cloud. Well, I thought that, well, let's go big. So what I did was that same morning, I set up a 80-core machine in Las Vegas to really go big. And while this competition was going on between my colleagues, what I did was I shifted around the workload. So I killed off actors here and there and spawned others, and I moved the workload from Las Vegas to Spain, and to a computer running at home, and so on. And throughout the presentation, there wasn't a single glitch. You have the possibility of getting a leaderboard that updates in real time in this game, and everything was running smoothly. And I had anticipated at least some bumps along the road, but nothing. It was running so smoothly, and yeah, really wonderful demo. And the other thing was with this demo was to explore the possibility of having a common code base that was not JavaScript for an application. So I have the same Rust code base for the game engine running in the client and in the actors, which is really such an advantage. And I mean, with Rust, I really love it. I look forward to having some more projects where I can use Rust, because I mean, compared to other languages, it's a great experience. I mean, you write what you want to happen, and once you get it to compile, once you get it past the borrow checker and so on, it actually often does what you want it to do, which is not. I mean, for some languages, it's not that common actually, unfortunately. So anyway, and also what I explored was this. This progressive web app concept, that the web page can install itself, or you can install it to be app-like on a mobile device, which I think it is great and really cuts down the adoption barrier, and also the concept of offline first. I mean, something that for normal desktop apps, it's pretty natural, but I'm glad to see it. To see it coming for web apps as well, that your app is fully functional even while you're offline. And also exploring responsive design. So I won't. I'm modest enough to admit that the interface could look better, but at least it looks as good as I can make it look, and it looks equally good, at least in every resolution. So that was those were those demos, but actually there is one demo left, and I hoped I would leave some surprise factor here for you at least. And well, this is the real reason why I stuck with this 80s theme, because I mean, this presentation itself is actually an application. So this is written in C++17. And this was, I mean, I was feeling nostalgic when I made this presentation, and I ran across DJGPP, and some of you may not be familiar with that. That's not surprising. It's a compiler that started as a challenge. It was Richard Stallman who said he claimed in 1989 that C++ was too complex to be compiled for MS-DOS. So DJ Delory took that as a challenge, and he made DJGPP, which is exactly that, a C++ compiler for MS-DOS. And actually, I discovered that it has been maintained to this day, which is really amazing. And then I used Allegro, which is a game engine that has roots in MS-DOS, and which also has been maintained pretty well. And then I could compile that to DOSBox. And the final piece of the puzzle is that DOSBox has been ported to run in the browser using WebAssembly. So this entire presentation, this part of the presentation, is C++17 code compiled to MS-DOS, running in DOSBox or emulated in DOSBox, which is run in a wasm virtual machine. So again, I mean, this is, I mean, with something like this, I mean, anything is possible. So yeah, I like to be amazed, and yeah, I hope you are as well. Okay, so that was that for the demos, and going back to this, going back to high res at last. So I wanted to conclude the presentation. I posted some takeaways from my experience with developing with wasmCloud in Slack. But I really think that this is a more general question that I can't really answer myself. And I mean, it's not a, I think it's a general dilemma, really. So I really like the concept in wasmCloud of a capability-driven architecture. And here I see capability for me is synonymous with interface, really. So having interfaces and acting as contracts between components. But this is a problem I've run across, I mean, over and over again in development, is that, I mean, the reason that you're using a particular package is often that you're after some kind of special property of that package, something that is not general, really, which is the reason often why that particular package has been developed. So often, I mean, it's not easy. It's not that easy switching out components. Really, you would wish that it would just be like Lego blocks that you could switch out. But generally, it's not that easy, because you have that dilemma of, I mean, should I go general, or should I go specific? But should I go coarse, and then it's too general and I lose those special properties? Or should I go very fine-grained and have all those special properties, but then there's no benefit really in having that interface based architecture? So that was just, I mean, something just to, as a food for thought, something to continue thinking about. Yes, thank you. And well, if you have any questions, just feel free to ask.
Eunice, was that a call to action here? Is this, or was there more that you wanted to talk about today?
No, well, that was that. That was the presentation. So thank you very much.
I loved it. The part where you were talking about the epics of tech, I think played softly on a lot of our hearts as far as what we're trying to do here. I know we're really close to the top of the hour. So I wanted to thank you for all the demos you've shared before. If you haven't seen those, they are linked in the awesome wasmCloud stuff that Brooks just shared. And Brooks, I know you had a couple demos that you wanted to share today, but we are perilously close to an hour. Can we bump your demos to next week? Maybe, would that be all right? Or is there anything urgent that you wanted to call out?
My call out is actually pretty small, pretty short. I can get it
before,
in the next 30
before
seconds.
We go to that.
Yeah.
Let's make sure. Does anyone have any questions for Eunice or other discussion that we'd want to extend on the call? Well, I think we'll take the final call out around the right layer of abstraction, maybe into channel, and we can discuss it on Slack. I think what I have observed in inviting people to debate that is that while the wasmCloud core team sort of makes a decision for default first-party capability providers, the power to the model, Eunice, is that because it's extendable, people can always make their own layer of abstraction. So I know Matt Gilbride, who's at Google now, has talked a little bit about that in some of his DynamoDB stuff. Was he going to make it more like SQL or more like KV because the interface supports both? But Brooks, I know we're really close to time. I'll hand to you for your quick call out, and then we can wrap today's meeting and pick up next week from there.
Yeah, great segue too. Matt Gilbride actually reached out to me just before the call and said that he was going to miss today, but that he wanted to give a quick update on the DynamoDB provider. So again, as we kind of talked about last week, he's working with a slightly modified version of the key value contract, and he's been working on implementing paging, which he has actually gotten done and started testing. So I don't really have anything to show from a demo perspective, but he reached out to me before the call, and I know that or many of us are interested in watching the progress here. So I just wanted to share some of that in Matt's absence.
Would you do a call to action and invite Bailey from Single Store? Just hit her up on Slack and make sure she's seen that. I know she was curious about that implementation for doing union support for the Single Store database. Would you drop that out? Maybe see if we can cross connect those two folks together, Brooks?
Sure, can do.
Awesome. I know we're past time, folks. Any last call outs or community announcements? I've got just one quick one. Acceptances have started to go out for WebAssembly Day, KubeCon EU. I think most of the people on the call submitted. I apologize if you did not make this submission. We had almost 40 submissions, and nearly a quarter of them were about wasmCloud. So there are a bunch of wasmCloud talks that are on, but we've got a great program that we're getting ready to announce for KubeCon EU, and I hope to see you all there. And there's lots of opportunities, and we're always glad to host a presentation here if you'd still like to give a presentation but weren't selected for Valencia. There's also a few other WebAssembly days in the works, more to follow on that next week. Any final call outs or community invites before we wrap up today? All right, as usual, I'll stop recording. Folks can pitter patter, hang around a bit. Have a great day, everybody watching at home. Cheers.